We want to figure out how much work it's going to take to pump water out of an inverted cone-shaped tank. It's given us some dimensions. We have 6 meters as the height of our tank or our cone, and then the cone's base has a radius of 1.5 meters. So the first thing you want to do in any of these pumping problems is go ahead and make a graph. You want to draw a picture, put it on a coordinate system so that you can derive equations from your picture. And so that's what we're going to do right here. Here's a 3D rendering of this particular cone, and I put it on a coordinate system, and I have the bottom of the cone at the point 0, 0, just to make some calculations simpler in these pumping problems. Let's go ahead and remind ourselves of the equation for pumping problems. I want us to get a visual here of just taking a slice, any random height along this cone, and then let's look at our formula. What we start with is we start with where our lowest slice can be. That's going to be our A. The B value is going to be the height of our highest slice of water that we take here. Density is going to play a factor in this. So in this case we have water, it will be the density of water. Gravity is constantly working against us when we try and push something or pump something up vertically. Gravity is pushing down on us. We also need a distance function, and that's going to be the height we have to pump every slice of water up to. And then the last thing we're going to need is we're going to need an area function. And that's going to be how big of an area that slice is. We know density of water is 1,000. We know gravity is 9.8. So we need to figure out our distance and our area functions. Well, our distance function actually isn't too complicated. The distance, once again, is just that distance between our random slice and the top of the tank. In this case, we can say distance is 6 minus y, and that will give us the distance between that slice and the top of our tank. Our area function is going to be a little more complicated. If we look down at the slice, we can see the area of that is going to be a circle. But the tricky part in this is we're going to have to find that length of the radius. And you can see as we take slices toward the bottom, that area is going to be smaller than when we take slices toward the top. So our radius is going to change. So what we need to do is we need to find an equation for that radius. And if we find the equation for the radius, we can plug it into the equation of our area, which is in the shape of a circle. So it's pi r squared. So let's look at that and try and figure out the length of our radius. Let's go back to our picture and let's take that random slice again. Our radius is going to be from x equals 0 all the way out here to our x. So what I need to do is I need to find an equation for this particular line. So I already said I have a point down here that I know that line goes through. And then I also have a point up here. I know where that point is. I know that that's 1.5 because that's our radius. And then I know the height of this cylinder is 6. I have 2 points. Slope is the change of y over the change of x. In this case, we're going to have 6 minus 0 over 1.5 minus 0, which is going to give us a slope of 4. Every straight line has an equation in the form y equals mx plus b. I know what m is. That's my 4. And I also just need to plug in any point on the line in order to find my b value. Well, in this case, the easiest thing I can do is plug in 0, 0. So if y equals 0, slope equals 4, x equals 0, then I have plus b, and I know b equals 0. I now have my equation of my line. I have y equals slope of 4 times x. Let's go back and remember the thickness of my slice is in terms of y, so everything in my equation has to be in terms of y. My distance function already up here, 6 minus y, is in terms of y. But this right here, I need to get it in terms of y, which means I need to solve for x. So I need to rewrite it. I need to divide both sides by 4. And I get x equals y over 4. This is also the radius of that circle. So once again, the shape of my slice is going to be in a circle. And the radius is going to be y over 4. I can plug that back into my area function up here. I can say my area is going to be pi r, which is y over 4, squared. So I'm going to have pi y squared over 16, and that's my area function. And now I've got all of the pieces except a and b. And let's go ahead and start plugging that back into our formula. The lowest slice I can have is at y equals 0. So that's my A value. The highest slice I can have is the y value at 6, because that's the top of the tank. The density of water is 1,000. Gravity is that 9.8. We have our distance function of 6 minus y. And we have our area function of pi y squared over 16. And we're multiplying that all by that dy value. I'm going to go ahead and rearrange some of these numbers in here. I know I can multiply those together and pull them out in front of the equation. Likewise, I've got that pi over 16, and I can also pull that out of my equation because these are just factors that are being multiplied and they're constants. So I'm going to have 1,000 that I can pull out. I have 9.8 I can pull out. I have pi, and then I have 16 in the denominator. I have my integral going from 0 to 6, and I still have 6 minus y times y squared dy. If I plug these values into a calculator, I come up with 19242.255. And now I'm going to go ahead and I'm going to distribute this y squared to each term here. So I'm going to get 6y squared minus y cubed dy. Now I can find the antiderivative and evaluate from 0 to 6. To find that antiderivative, I add 1 to the exponent and divide by that exponent. And then I evaluate. Six divided by 3, this just goes to 2. And I'm going to plug in 6. 2 times 6 cubed minus 6 to the 4th over 4. When I evaluate at y equals 0, everything just goes to 0, so I can ignore that part. And here, when I take 2 times 6 cubed, I get 432. And then when I take 6 to the 4th power divided by 4, I get 324. When I plug that into the calculator, here's what I end up with. And this is in joules. This number's a little big, so this might be where we start thinking about putting things in scientific notation. If I were to do that, I'd come over here, 1, 2, 3, 4, 5. And I'd go ahead and I would round, and I'd say 2.08 times 10 to the 5th joules.